Astronomy Department. I'm president of the Society of Physics Students. And here are my friends. So come on guys, go ahead and line up. Go ahead and line up everybody. And I'm going to jump on stage. And everybody go ahead and line up right here in front of the table. And in the physics department, we have something that's pretty unique. We all come from different places. From even some of us from different countries. And myself, I'm from Los Fresnos, here from Los Fresnos, Texas, next town over, right next to Brownsville. And now I'm working on my master's degree in physics. And a lot of us here are actually physics students, and some are special friends of ours. So I'm going to pass down the microphone, and everyone's going to introduce themselves. So here you go.
I am Luis,
Hello everyone, my name is Ayo. I'm from Nigeria, Africa. I'm a master's student in physics students at UTB.
Hello everyone, I'm James Santiago, and I come from China. I'm in physics. I believe our show will going to make you explore your mind. Feel great, okay? Science will make the world better. Trust them.
So glad to meet you all. Hope you all have a good time.
Hi, I'm Erin Curl. I'm from Brownsville.
Hello, my name is Andres. I come from my mother. I'm from Los Fresnos. I'm just kidding, guys. So we also have two more people. Our cameraman right here, his name is Martin Diaz. He comes from his hometown is Piedras Negras, correct? Yeah. And here on this side we have our great advisor. His name is Robert Stone, and he's born and raised in Brownsville, correct? He's from Brownsville. Alright, so let's get started, shall we? So here we have our friend Gene. Gene is he has this balloon and he has a pump. Now, who can tell me how a pump works? Let's hear it.
Ladies and gentlemen, we raise our hands and wait.
Oh, it's okay. It's very interactive. They can go ahead and shout it out loud. So go ahead. So now, let's see what happens. He's gonna, what's going on? This good? Okay. So go ahead and start putting air. So we'll see what's going on is the pump gets air from around the atmosphere, right? Now, the pump starts pushing the air into the balloon. Now, the balloon has some properties of elasticity, so it starts stretching. You see? Now, it's getting filled up with air. It's getting filled up with air, and what do you think is going to happen if it keeps on filling it up with air? It's going to pop. All right. So now you guys should be aware that there will be a pop, right? So let's get ready. Keep on going. But we never know when it's really going to pop because it's pumping the balloon and. All right. So then what happens? It pops. Why did it pop? There's too much air. Now, here we have something special. It's a 2-liter bottle. Now, in this 2-liter bottle, the 2-liter bottle also has some elasticity properties, right? So it can only stretch so much. We can show the same effect, but this time with special gas. Well, it's actually a liquid, a special liquid that we have in a special container. And here it is. Have you guys ever heard of liquid nitrogen? Yes. What's so special about liquid nitrogen? It freezes things. You guys know how cold it is? It's minus 273 degrees Celsius. Minus 273 degrees Celsius. So what they're doing is they're filling up this bottle with some of this liquid nitrogen. The liquid nitrogen evaporates. The liquid nitrogen evaporates at room temperature. So here, I do have to say that you have to be careful with this. It's very cold, and this next explosion is going to be really loud. So guys, be ready. This is really, really loud.
So you're not so cool. Cover your ears.
Cover your ears.
Okay.
This is all that's left. This is all that's left from the explosion. So this is very dangerous, right? Now, this sort of things you shouldn't try at home. Now, I always start off by asking, who here is interested in science and math? That is a great response. Now, I do see some hands that didn't go up. I don't know, maybe you're shy, or maybe you're not that interested, but I really hope that you really enjoy the show and that I change your mind and you do become interested in math and science, because that's always sunny here. So right now what they're doing is they're pouring some of the liquid nitrogen into a larger container, and they'll bring this container right out. Now you'll see that, remember, it's minus 273 degrees Celsius. So when you see it, it's actually evaporating. So the very first thing we do is we'll grab a banana and we put it to cook. Alright, now how do you know when something's actually boiling? So have you guys seen a tea maker before? So how do you know when the tea's ready? It makes a noise. So let's see if it does the same thing here. Tea's ready. All right. So we saw something blow up with the liquid nitrogen. So now I have a balloon. What do you think happens if I put the balloon in the liquid nitrogen? Wait. What's going on with the balloon? So the air is freezing, it's losing air. Maybe it has a hole. Let's see what happens. So the air is coming right back. Here we have another balloon. Let's see. Maybe there's something funny with this balloon. Maybe that balloon will do something. It's frozen. You can hear it. Hear the crackling? Okay, there we go. So there we go. Now the balloons go back up. Now how is this possible? What's going on? So inside we have all these air particles. They're moving all around. They're going in all directions, right? Now if they get cold, they do what we usually do when we get cold. We're inside. We're nice and warm, and suddenly we go outside and it's very cold. And we get all close together and we start, getting really close together. That's exactly what happens with the air particles inside the balloon. So here we have some flowers. Let's talk to Mr. Flower real quick. Mr. Flower, what do you have to say? What do you have to say? Oh, he doesn't really speak. So let's see what happens when we dip them in liquid nitrogen. Now let's squeeze the frozen one. So what's going on? It's freezing. How's the water freezing? Flowers have what's called a high water content. They contain a lot of water inside of the petals. So whenever we dip it in the liquid nitrogen, which is really cold, it gets frozen. It gets so frozen and that it gets brittle. It gets very brittle. That way, whenever we touch it, it breaks. It almost seems like glass. So go ahead and smack it on the table. See what happens. All right. So we saw something blow up. We saw something freeze and break. It's boiling. And now we have a piece of wood. You know, maybe sometimes you want to do some woodwork in the house. Maybe you want to make a birdhouse. You find some wood. You find a nail. And all we have is a banana and some liquid nitrogen. Fortunately, we forgot our hammer, but I think we might be able to use this. I'm not sure. We've tried it a couple times, but let's see what happens. We have a banana that we've had in the liquid nitrogen since we started, and it's real. It's a real banana. And here it is. And let's see what happens. It's as hard as a rock. So, now you know, if you're in the wood shop and you need a hammer or something, you can use a banana and some liquid nitrogen. All right, and yeah, it is a real banana. All righty, thank you guys. So, now here we have some more liquid nitrogen. Now it comes to my favorite part of the show. My favorite part of the show is what happens if you mix something that's really cold with something that's really hot. Oil? Yeah. A tornado? Well, let's see what happens. Now, what we're going to do is we're going to set up a container down here. We have our container down here, and we're getting it ready. And let's see, I'm going to come down here. Now, I have some water that's been boiling ever since before the show got started. So I have something that's really, really hot, right? Now, the liquid nitrogen, like I said, is really cold. Now, here I have this container. So, everybody bring the container down? Yes. I have this container. Right. Now, ask for the liquid nitrogen to please come over here. Everybody, welcome to liquid nitrogen! Yeah, with the liquid nitrogen, we're going to pour the liquid nitrogen in here. And you'll see it evaporating as it's coming out. All right. That's good stuff. Now I'll ask for a cinder block.
Yes.
Yes, we're going to get a cinder block. Now this is for me to stand on. That way I get really tall. Thank you. Now you might be wondering what this tarp is doing in this area, and we'll soon find out. So here we have boiling water, and it's hot. Is it hot? So it's hot. So I'm gonna ask for here's some gloves and safety goggles. All right. Now safety first. Are you guys ready? So you're gonna help me out. So what I'm gonna ask is that everyone count down. We're gonna start at 5. We're gonna start at 5, and we'll work our way down. All right? Well, we're gonna find out. Should you cover your ears? It won't be that loud. It won't be that loud, but it'll look nice.
Oh, okay.
Are you ready?
Yeah! 1, 2, 3!
air is mostly made out of? Nitrogen. The air is mostly made out of nitrogen. It's important that we have oxygen in there as well, but it's a very small percentage compared to nitrogen. So, alright, thank you so much. So here we go. Now,
Take it away. Yeah, take it away.
have you guys ever heard of a man by the name of Sir Isaac Newton?
Hey, wait,
So,
can you help pick this up?
what's so special about him?
Wait.
Motion, that's very good. And that's exactly what we're going to talk about right now. The 3 laws of motion. So, who can tell me Newton's first law? Yes? Force? That's not exactly the answer. So, first law of motion.
Get on the other side and pick the tarp up. Like move it over. Wait, but go around behind him. Go behind him. Go behind him.
Oh, yeah. Very good. Alright, so very good. So, an object in motion stays in motion while an object at rest stays at rest. So here, my friend Crisco, he set up the table, and he was gonna have a fancy dinner, but then he noticed that they actually ordered pizza and not the fancy dinner. So he didn't want it to be that fancy. So he wants to take this off without messing up the rest of the table. So what do you think he should do? Roll it really fast? Alright. So before we do this, I'm gonna ask you guys can get closer now. We cleared the area, so everything is safe.
Whoa. A little bit back.
We need a little bit of space. We need a black line.
Back it up. Back. You're still in front of it. Back. Let's keep feet in front of it. Back.
Back a little bit. Everyone gets back. Alright.
I love that.
So, are you guys ready?
Okay.
Everybody set? Alright. So now, you use a lot of concentration. We're going to help them by counting down to 3. Ready? Alright. Now, 3, 2, 1, go! Very good. So what was in motion? The tablecloth. And what was that rest? The dishes, yes. So then we saw that the object in motion stayed in motion and the objects at rest stay at rest. Very good. Alright. Now, thanks so much. Now we're going to move on to Eaton's second law.
One. The little girl in the far back. The little girl in the far back. Yeah.
Alright. So here, I heard you guys saying tug of war, and that's just it. They were actually having an argument earlier, and they couldn't decide what the right answer was. So I told them, guys, how about we settle this with some tug of war? So here we have Robert on the left and Ivan on the right. So who do you think's gonna win? Alright. So we're all gonna cheer on, ready? So we're gonna count them down and they'll get started. Ready? 3, 2, 1, go! What's going on? Horses, but they're not moving. Why aren't they moving? They're both pulling. So what does that mean? There's one person on that side, there's one person on that side. So they have balanced forces. So since there's balanced forces, there is no motion. Now, let's see, what if they got some help? So let's see, let's get some help. Okay. Alright, so here we go. Now we have reinforcement. Now who's gonna win? Alright, now let's try again. Ready? 3, 2, 1, go! Whoa! What's going on? You guys aren't moving.
Because they have the
Let's put everyone over here. So, Aaron, let's do this one. Alright. Who do you think's gonna win?
Pablo!
Let's see. Ready? 3, 2, 1. So what happened? Yes, Pablo was. Now, you saw that everybody was going in this direction, right? Why were they all going in this direction? Exactly, because there's more force on that side. So objects travel in the direction of the most force, right? So now we're going to quiz you guys. We have another demonstration that really puts this to the test, right? So here we have this very large spool. A spool, you can think of it like if it's a big yo-yo. Have you guys ever played with a yo-yo before? Yeah? Alright, so here we go. Now, we have this spool. Now, can you lean it forward so they can see? Alright, now the spool, the rope is going around, and over the spool, okay? So, the rope is going over the spool. So go ahead. Alright, let's move a little bit more towards. Alright, better time. Now, which direction do you think it's going to go? Show me with the arms. Is it going this way or is it this way?
This way.
Okay, most of you are saying that way. Some of you are saying that way. Let's see what happens, right? 3, 2, 1. Okay. That makes sense. We'll do it quickly one more time just to make sure that everything's fine. Again, the rope is going over the spool, so go ahead. 3, 2, 1, go! Alright. So that makes sense, right? So what if we flip the spool over? So what if we flip the spool over so it's going under? It's going to go this way? Okay. So you see now the rope is going under? Okay. So if she pulls it, which direction should it go? That way. Okay, so everyone's saying this. Alright, are you ready? Okay, we all have to make sure. Alright, now we start in 3, 2, 1! Whoa, wait. We're practicing earlier. It worked earlier, I swear. Let's see. I don't know.
Hey, no,
I think she might have broke it. Let's try it again. Let's try it again. So ready? 3! Wait, are we ready? Okay, here we go. 3, 2, 1, go! Oh. Wait, what? It's missing. Maybe the stage is crooked, and that's why it's falling that way every time. So try going this way.
She has an ace hat. Ma'am, pick up the ball.
Alright, so here we go. Now, go ahead. Ready? 3, 2, 1, go! Oh. It still keeps on going towards her. She's pulling towards her. What does that mean? You're on to something. Exactly. The force is going in this direction. And I heard some people saying that maybe she's just pulling too high or she's pulling too low. So what happens is we pull it up and pull it up. Because he's still going towards her. And does he try it from a lower position? This is independent of how she's pulling it, whether it's high or whether it's low. Now, she's pulling it towards her, and the object is going in her direction because the force is going towards her. Yeah? Alright. So, thanks so much. Now, here we have another game with the rope. Now, this one isn't necessarily. Guys, I'm gonna ask you to come on, sit back down. Yes. So here we have another really getting really all the back in here. Now, this one, we're going to bring it down here. And I think there's 2 or 3 people. So, everybody round of applause. Here, we're going to play a little different. We're going to play a game. It's not such a word. For this one,
Tell the girl what to do, Lily.
is make sure that
Stay with her. Tell her what to do. Oh, no.
So we're going to make sure that the rope is straight. Alright? So you guys have to watch for us, alright? You tell us that to make sure that the rope is straight. She's going to be on this side to make sure that they're actually keeping the rope straight. So you guys ready? So this isn't tug of war, guys, alright? This isn't tug of war. It's not limbo either. So what she's going to do is you're going to put your hand here. And you're going to make sure that it's straight. So you're just going to pull it down to make sure that they're keeping it straight. So is it straight, guys? No. Okay, guys, pull hard. So go ahead and push. Is it straight? No. Alright, guys, really pull hard. Really pull hard. So I don't know. We have 2 strong guys here. Alright, guys. Alright, I think you guys have enough. Let's see if maybe they just need more help, right? Maybe they're not putting enough force. Right, so let's get 2 more assistants. So come on up. Alright, so let's see. We have 2 people on that side, 2 people on this side. So everybody cheer on for Jasmine. Who do you think is going to win? We have 4 guys and 1 guy.
Jasmine!
So everybody. So you guys are pulling? Let's see. Make sure that you're pulling. Let's see. I don't know. I think she's still. Alright. Round of applause for Jasmine. So, what happened? What happened here? Jasmine, she's so small, but yet she beat the 4 big guys. Alright. So, let me tell you. We had 2 people on this side, and they were pulling in this direction, right? Then we had 2 people on this side, and they were pulling in this direction. So we had balanced forces in that direction, in this direction, right? Now, we had Jasmine pulling down, but who was pulling up? Nobody. There were unbalanced forces. And it goes back to the same thing that we were saying earlier. The objects move in the direction with a greater force. Since she had no other force pulling up on her, there was no one to fight. So she was able to pull down the rope with no problem. So thank you again, Jasmine. Thank you again. Right. So now we move on to. Alright, so actually now we have something called momentum. Have you guys ever heard of momentum? Momentum. So you can think of momentum as transferring energy from one object to another. Now momentum depends a lot on the mass of the object. Do you guys know what mass is? Yes! And so we know that mass is the number of particles that are inside of this object. So which one has more mass? This one or that one? That's more mass. So what do you think is going to happen if, actually, first I have to ask, so if I let this ball go, will it ever come back to the same height? Yes? No? So we're going to do something that we always do in science, which is test things. We're going to test our hypothesis. So will this come back to the same height? I hear some people saying yes, I hear some people saying no. So let's see, ready? 3, 2, 1. It's gonna come back to the same height. So here we go. Now let's do the basketball. Will the basketball come back to the same height? Yes. All right. Ready? 3, 2, 1. So in it didn't come back to the same height. So what happens, what do you think would happen if we were to hit the ball with most mass on top of the ball with little mass? Alright, so ready? We're going to test it out. Now, 3. Wait. Well, actually, I have to say, be ready if the ball comes in your direction. Be ready to catch, okay? Okay, here we go. Now, 3, 2, 1, go. Okay, so it's stayed pretty low to the ground. So, what do you think will happen if we do it the opposite way? Well, if we put the more massive object on the bottom and the least massive object on the top. The ball's going to go far. Alright, so now let's see what happens. Ready? Be ready to catch. Now, 3, 2, 1. Alright, so the ball is flying now. So, this is something that you could try. Here we go again. Ready? 3, 2, 1. Okay, so now okay, so gloves for safety reasons. So we're doing a lot of concentration for this one. So my friend Andre recently applied to be an astronaut for NASA, and he really wants to be in the rocket, but they haven't called him back. So he decided to make his own rocket. So guys, I have to say, do not try this at home because this is very dangerous. I have to say that this is very loud. So you guys might want to cover your ears. Alright, who's going to give me the sound? Ready? Alright, you ready? Alright, remember, you're a professional, do not try this at home. We're going to count them down from 5. T-minus 5 seconds. 5, 4, 3, 2, 1, go! And he's up to the moon! Alright, guys, I have a question for you. So, who can tell me what Newton's law that was? So, do you guys know what Newton's law that was? Momentum? It's the third law. It's also known as the law of action-reaction. So, he pushed the fire extinguisher, right? And all particles were going out in that direction. There was nothing to hold them back, so he started flying out in that direction. So thank you so much. So, here, have you guys ever heard of a guy by the name of Bernoulli? Bernoulli said a lot of cool things regarding air and fluids. So, guys, I'll come back over here to the 6th seat. Now, that way everyone gets a fair chance to see. So, come on, guys. So, this one is another one that you could try at home. So here we have a normal air dryer and a ping pong ball. Now, if you turn the air dryer on, you'll notice something interesting happens. Bernoulli said that the faster moving particles create low pressure. Now what happens here is that the air starts going around the ping pong ball. This is the most interesting part, that the air is going around it, so it's actually not just going around it, but it's like if it's holding it in place. So you're able to do something that's pretty interesting. Now look. It's floating over my hand, but there's nothing there holding it. It's just the air. The air is like going around the balloon, around the ping pong ball and holding it right in place. So can everybody see this good? I don't think so, because there's some people in the back and I'm not sure if they can see it. I think we should get something that's a little bigger, yeah? So here we go. I think we have a ball that's bigger. Now, what do you think is going to give us a lot of air? A leaf blower. Here we go. So here we go. We have a little piece of toilet paper. Now, here's another demonstration that you can try at home. So guys, okay. So here I have a piece of toilet paper. This one you can try at home. This is completely safe. So here we're going to do the same thing. We're going to create what's called lift. Do you know where we see lift every day? It's airplanes. Airplanes use the same concept of lift. So here, all we're going to do is I'm going to blow over this piece of paper. So now you see that by blowing over the piece of paper, the paper will actually go up. The paper's going to go up rather than, because if you blow into the paper, it makes sense that it's going to go up, right? Here we go. That makes sense. But what if I blow over it?
No, nothing won't happen.
Ready?
Yes, ready.
So you see, I was blowing on top of the paper. Now we have something to actually make this a little bit more dramatic. You guys want to see this? Yeah? Alright, so let's bring up the leaf blower again. Let's break the rest of the toilet paper out. Now, again guys, you guys have to pay attention to this. Science should only be used for good and never for bad. Alright? Never do anything evil with what you're about to learn. Now here we go. You guys ready? 3, 2, 1, go! you ever want to step on one nail? No, because that would hurt. So, we like to do crazy things sometimes. So, we're going to ask our friend here, Luis, to lay down on the bed of nails. So, go ahead and let's see, come this way. There you go. Now you want to spread your back all across. There you go. All across the bed of nails. And here we have a nice little pillow. It's made out of toilet paper. And you need a pillow with that, right? So here we go. Now you see, he's perfectly fine. How are you doing? How are you feeling?
It's no, I
Okay, that means it's good. He's fine. So now everything's fine. He's not going through. But what do you think if we add more weight? You think he'll go through? So let's try it out. We have this board. Now we have this board and it's adding more weight on him. Let's see. Let's get the mask on him before we go any further. Now go ahead and put it over yourself. Make sure that it's nice and tight. Yeah. Now bring it down to your neck. Make sure nothing can. All right. So what if we add even more weight? Alright, so there you go. Alright, so now we have a lot of force. We have a lot of force coming down onto him. Now, we need to find another way to add a lot more force. So, it's very dangerous. So, I don't know if you guys see anything on stage that we can use to apply a lot of force coming down. So, do we have, oh, there we go. Uh-oh. Can you guys see where this is going? Alright. So, for this, he requires a lot of concentration to make sure that everything goes well. So, we'll ask everyone to be silent. We need silence. And do not try to sit home. No, do not try to sit home. No, we're going to count from 5 and work our way down. Ready? But after everyone is silent, I'll start us off. 5, 4, 3, 2, 1. Very good. Let's rescue him. Rescue him. Make sure everything's okay. Now he gets up. Mr. Come on to the front. Round of applause. There are no holes on him. So, very good. Thank you so much. Congratulations for surviving. So, here, explanation is simple. We have lots of points around him that are actually distributing the force. Now, that way, none of the nails, like none of the individual nails, are providing that much force to actually puncture through him. And that's why he was safe throughout this entire process. Now, I have one more question for you guys. Who here likes science and math?
Me! I like science.
Yes. That means that we have done what we came here for. We have encouraged all of you to study science and math. Also study computer science because it's very important. And thank you so much. We are from the University of Texas at Bronxville, the Physics and Astronomy Department. And thank you guys so much. And I hope you guys enjoyed the show. All right, so now I'll have the teachers take over.